So we continue with the discussion. The control systems represent the first module represents the full mathematical modeling, wherein the block consists of some kind of representation of physical phenomenon into the transfer function. So the circuit will be consisting of, as again I repeat, resistor, capacitor, inductor. Now we add op-amp, that is amplifier, and adder. So once that is done, means control system. The linear circuits or circuit theory was primarily consisting of passive systems, but here the major focus on active system, because we can't have a concept of feedback unless we incorporate what is the need for feedback. How can we incorporate concept of feedback wherein we have to add something by scaling. Scaling with gain less than 1 is possible, but adding is not possible unless we use operation amplifier. So we will go with various systems, and then the transfer function is very simple, wherein the derivative d by dt is represented by s. So you should be able to find out the transfer function, and once we are able to represent a block wherein there is an input, there is system and there is output, the system, that is the block, is represented by a mathematical formulation, that is transfer function Hs. So I would like that you should instantly derive the determine Hs for this whole system. So let me check whether you are able to do that. Be quick. So I will now stop. We will go with. I will go along with you. So what is this transfer function? And when we now, there is no need for us to develop each time differential equation. The inductor impedance is S, inductor impedance is Ls, capacitor impedance 1 upon Cs, and resistance impedance is R. So with that we are able to find out. So this gets reduced to, am I right, say this one, and once it reaches to S, it becomes high school level scholarship problem, very simple. So what is this? S upon S plus 1, right? S upon S plus 1. And while writing input and output, we write in V in S and VOS. So this you may now pseudo understand right now. So what would be this then? Ultimately it becomes very simple expression. So this would be, I will take as VAS, right? I will call this VAS. So we develop further. Input is V in S, this is VAS, this output is VOS. So what is VOS now? What we want? We want to find out overall transfer function. How? By VOS is sometimes V in S. So VOS here is what? S upon S plus 1 into V. Is it right? Do you agree? But what is VAS? What is VAS? VAS is V in S plus 8 times VOS. Now see, since it's a high school level scholarship, when we used to ask some highly analytical questions, everybody was keeping quiet. And now, as it is so simple, everybody will start Adimi circle. So VOS is equal to V in S plus A into VOS. The Laplace transform is said to be commutative. What we can say? Distributive, associative, commutative, like that. So this you put there, so that's all. So VOS is equal to S upon S plus 1 into V in S plus A. Is it right? Is it okay? So then VOS is equal to S upon S plus 1 into V in S plus AS upon S plus 1 into VOS. Is it right? So how do we proceed further? What is the method for proceeding? Simple method. Take this on the left hand side. So we get VOS minus AS upon S plus 1 into VOS is equal to S upon S plus 1 into VOS, right? Is it okay? So, what is the better method? Multiply it on this side. So, VOS into bracket, or sometimes multiplying each term by S plus 1, that may simplify. So, S plus 1 minus A minus AS VOS is equal to S. So VOS is equal to S upon how do we write? We write as 1 minus A into S plus 1 into. So HS or overall transfer function is equal to S upon 1 minus A S plus 1. What will happen if A is 0? If A is 0, then as well as no feedback, S upon S plus 1. What happens if A is 2? If S, oh, you answered it, I thought it was quick. If S is A is 2, then 1 upon S upon 1 minus S. If A is 1, then transfer will be S. Right. So transfer function S means there are some transfer functions which can be achieved by only passive components, but for some transfer functions we need to include active components essentially. Means if you want denominator to be only S, or if you want denominator to be poles on left hand side, it is 1 minus S like that, you have to go for active components. So we proceed next. So now, in general, we can work for any circuit. So let us say for time being, in this block, we may include this. Again 1, 1. And in this block, so can you do it quickly? Or in general, henceforth there may not be any need for writing these components as such. Direct, this you can parallelly go with. Or we write input. Now, in general, so you do this and after that you can do it quickly. Attend a second. So what will happen? So in general, so the steps are very simple. Whatever may be the circuit, reduce it to its mathematical model in transfer function. So transfer function HS, and once you are able to reduce it to transfer function, it simply becomes a algebraic calculation. So in general, what this would be? I think there is no, we can solve it separately, but once we are able to solve this completely, all kinds of problems can be solved. So this here, VOS, or now we will not use term VO, we will use term YS is equal to this. You need to give this input, you can use by X, this you can use by W, so Y, and this you can use some other variable, say P of S. Right. Or P sometimes we use for numerical denominators, we use a W of S. So Ys is equal to H1S into Ws. What is W? I again repeat, when we say input and we say it in terms of S, it is Laplace transform of V in t. Laplace transfer function tells us, the S domain transfer function tells us that if input is e raised to st, output is that into e raised to st, or if I apply input whose Laplace transform is xs, then inverse Laplace transform of ys, which is equal to xs into hs, would be my output. So ys is equal to hs into ws. H1 is into ws. But what is ws? ws is xs is xs, right? Plus
H2S.
this is g1 plus g1s into y of s. So, is it right? Right. So at least you were curious. So she asked the question. So what is done? At this one, it comes in G1s, right? So how it can be proceeded? It's very simple then. Again, high school, you finished? So what is HS? You have to. What is HS? Final answer? No, not that. Not that. This one. This one.
1 upon S plus 1.
In terms of H1s and G1s, that's all. So don't go for, now that example was just for practice, this should be a general method. So what it is, so ys is equal to h1s into xs plus g1s into ys. This is feed. What happens is that because of concept of feedback, the output includes part of output on the right hand side, because it gets input which is fed back. So ys is equal to h1s xs plus h1s g1s ys. Taking this on the other side, ys, this is ys plus this. So I hope this step we can overwrite. So ys is equal to h1s upon 1 minus h1s g1s into xs, or transfer function overall hs is equal to h1s upon 1 minus h1s g1. Is it right? So this is the answer for this. So in general, I will draw it fresh. So this is the transfer function for when I have right? So this is means the feedback block. Otherwise, then few further things are there that need not be stated. what this would be? Input H1s H2s output. Directly, what would be Hs? Multiplication of H1s into H2s. Multiplication of H1s into H2s. What this would be? Addition of H1s into H1s and H2s. When I cascade like this, okay, so this you know. So I would like to ask you a simple question to find out. What it would be? Can you find it quickly? What will happen? What is the answer? Will it be 1 upon s square plus 2s plus 1? Then or 1 upon s square plus 3s plus 1? What it would be? What is this? What is this? So is it 1 upon s plus 1 into 1 upon s plus 1? Yes or no? Why not? Right, so he has understood very properly. When we say that, listen very carefully, when we say that I am connecting these two blocks, what is meaning of this connection? Meaning of this connection is when I connect it with an isolation, an emit voltage follower or unity gain buffer is added. So when this is added, in that means the block is expected not to get, means when the output of the block is expected not to get loaded by the further blocks, if this is insured, this is insured by this one. Otherwise, this becomes, I think in last semester itself we have done, it becomes 1 upon s square plus 3s plus 2. Because here, this no longer remains. This no longer remains means this output no longer remains this upon this plus this. This series combination of 1 and 1 is coming in parallel with this. And then this entirely represents the impedance here. This impedance upon this plus this is here. And this impedance, so this remains 1 upon s plus 1 as regards to this and this is concerned. But between this and this is no longer 1 upon s plus 1. So once that is very clear, there can be huge block, means this can be a good puzzle. Huge block diagram reduction techniques. So how can we finish this? So this is very means for lazy intellectual class of people. This is very good. It's a good syllabus. That no much preparation is needed. Based on common sense and general aptitude, it can be solved. So, what is the immediate steps needed? Immediate steps needed are name these intermediate points. This is xs, this is ys, this is now, we can give some other simple names. Say, let us say as, there is no problem, and this, which is to be done, this one. AS and this is BS. So how do we proceed? We write simple steps. What is the first thing which you can write? AS is equal to XS plus G2S BS. Right? No, sorry, not BS. G2BS, right? What is B2 BS? BS is equal to, what is BS is equal to? What is BS? BS equal to? Right. So इथं फक्त H आधी लिहायचं म्हणजे एक मेथड म्हणून काय फार फरक पडत नाही पण कन्व्हेन्शन H1SAS प्लस G1S into YS. आता YS कसं लिहायचं YS is equal to main equation YS is equal to H2S H3S BS बरोबर आहे YS is equal to this into H3S what is this this is BS right this is BS into H2S so H2S into H3S into BS so how do we proceed ahead huh
G2S plus H2S into BS.
A of S is
X of S plus G2S into H2S.
A of S is equal to XS plus G2 or right oh it's very nice that म्हणजे मी तुम्ही याला काय बघायला मी केलं नव्हतं पण इट्स व्हेरी नाईस चुकून राहिलं पण इट्स व्हेरी नाईस दॅट यू आर दॅट So what will happen? Take this is master equation and proceed further. So this is YS is equal to H2S H3S into this H1S AS plus G1S YS. Is it right? Then next H2S H3S H1S into H1S AS plus G1S YS. But in AS again BS comes. So how do you resolve it? So we write fresh. You tell me what is what is AS? AS is equal to क्या होता? X of S plus G2S H2S BS. What is BS? H1S AS, right? G1 S into Y. Yes. आणि पुढे काय लिहिलं आपण? Y is equal to H2S H3S into D. So now what will you do? How do you proceed? You just look at see how mixing, very effective mixing has been done. That a cross means interdependency. This goes here and this comes here. So is it something which is impossible or undoable? Is it something impossible or undoable? No. But if it is doable, not so easy. So when you put Ys is equal to H1S, when you put here H2S, H3S into bracket, I separate the bracket. Ps is H1S AS plus again this H2S H3S G1S into Ys. So Ys into bracket, this comes as 1 minus H2S H3S G1S is equal to, we don't make it square right now, H2S H3S H1S into AS, because that is required because X is there in HS AS. So into this into XS plus H2S H3S H1S G2S H2S BS. BS? How can you do that? BS is right, so
that A term will not come in.
so here this BS is
Ys.
Ys upon H2S H3S.
Then again Ys come.
So, or simply, rather than what you say, putting divide, you can simply look for this term. So, BS is there, H2S is already there, and H3 is already there. So, this I can write as instead of this, I can write as H2S, H1S, G2S, Ys. Is it right? So that also comes on the other side. Also comes on the other side. So Ys into bracket 1 minus H2S H3S G1S minus H2S H1S G2S is equal to H2S H3S H1S XS. So H2 is common and in the bracket H3G1 plus H1G2. So we may proceed here that Ys into bracket 1 minus H2S into further bracket H3S G1S plus H1S G2S double bracket is equal to H1S H2S H3S XS. So ultimately into XS, right? So overall HS is equal to H1S H2S H3S upon 1 minus H2S into bracket H3S G1S plus H1S. Is it right? Is it okay? So I think remaining you are also